Hello and welcome to this session on the Global Livestock Environmental Assessment Model Interactive, also known as GLEAM-i. My name is Ruben Martinez and I will demonstrate today how to use the tool and also will provide step-by-step examples on both cattle and pigs. GLEAM-i or GLEAM Interactive is the first public and user-friendly tool that is available to simulate production and intervention scenarios in the livestock sector in the context of greenhouse gas emission mitigation. The tool consists on an Excel file that can be downloaded from the FAO's GLEAM website, and once we open it, we are prompted to the start page that we are seeing right now. GLEAM-i is organized into three different modules that represents the main stages of livestock production, as it shows in the top navigation bar. The first module is the herd, the second module is the feed module, and the third one is manure. That, of course, replicate each of these stages, as we said. Besides the navigation bar at the top, which is present throughout all the pages in the tool, in the start page we can have a look at the following elements. First, we have a brief welcome message from the team on the top left. Second, we have a very short reminder on how to use the tool and how to navigate between the different modules, which is called GLEAM Basics. Third, we have a square where we suggest how to provide feedback to the team regarding the tool, and finally an official disclaimer regarding the use of the tool. Since GLEAM-i works on a country basis, to start using the tool, we have to select a particular country where we want to run our simulation. So, for instance, we're going to start by typing the name. In this case, we're going to take Kenya as an example. So we will write Kenyan example GLEAM-i tutorial. And as a second step, we have to select the region from this drop list and the particular country. Okay. Once we press the Start Simulation button, the simulation actually starts. As we can see, we're taken to the herd page, in this case cattle, as it's highlighted in green. The tool covers the main six livestock species, 4 ruminants and 2 monogastrics. We have cattle, buffaloes, sheep, goats, and pigs and chicken, that we can easily navigate through the different pages by clicking either the particular species or by using the previous and next arrows. The first part of the model, of course, consists in the herd module. What this module does is to simulate the dynamics and the structure of the herd based on the animal numbers and also different herd characteristics such as death rates and mortality and fertility. The layout of those pages is very similar throughout the through the different species. At the top, we have a short reminder of how to use the particular page that we are on. In this case, how to use the herd. And in the second part, we have, in this case, the definition of the 2 production systems that are taken into account. If we scroll down, we'll see 2 boxes. The first one contains data on animal numbers, and while the second one contains all the parameters that are necessary to simulate the herd in this case. Another common element throughout the entire tool is the color code of the different cells. As we see, we have light blue cells, white cells, and in this case, gray cells. The light blue ones represent the default values that depends on the country that we have selected. For instance, if we don't have data available on a particular aspect of our simulation, we can rely on those numbers either as a reference point or to use them directly in the simulation, since those values come directly from the database of GLEAM. In the white cells, however, we are able to change any value that we want, so we can accurately describe our system or a particular situation, and of course to run a scenario and change the parameters to allow for this simulation. So, for instance, what we're going to do it's to implement a particular scenario for cattle. However, before changing any parameters, I will take you to the results page, which can be clicked directly in the navigation page to see the baseline scenario. That is to say that the results we are seeing now, it represents the situation where no changes have occurred. So this is our baseline default values in terms of animal production. It's organized into different commodities. So in this case, we have meat from different species, milk also from cattle, buffalo, sheep, and goats, and finally we have the production of eggs from chicken. The second part of the results is the total emissions and the source of those emissions. As we can see here, that's the total gross emissions of the livestock sector, in this case for Kenya. This graph here describes the main sources of emissions per species, divided as feed, enteric fermentation, emissions coming from manure, and emissions from energy use. While this graph shows the share of each greenhouse gas emissions in the total amount. If we scroll a little bit more, we will see that we have a more detailed breakdown on the source of emissions that you can see clearly in the Excel. It's defined each of the source, and a brief comparison between Tier 1 methodology and our model, which is based on Tier 2. The last results are the emission intensities, where we compare the amount of greenhouse gas emissions per kilogram of protein for different livestock products. And we compare the particular simulation with the regional average in each case to be able to see how we are performing with respect to the region. What I want to point out is that this is the summary, but of course we can go to the detailed numbers. If we go to the top navigation bar here, we see all the species. So for instance, if we click into cattle, we see the specific breakdown of all the emissions by system. So for instance, here are the grassland numbers and mixed system values, but also split into both herds. In this case, the dairy part here and the beef part over there. In the case that we want to run a scenario, it's of course paramount that we first save the default values that will be our baseline scenario. So what we're going to do now, it's to store it. We can easily do this by saving the file, and we can call it, for instance, Kenya baseline. And this of course will allow us later on to very quickly see what are the difference between our baseline and scenario. If we go back to results here down below, we can go back to the herd page. Once we are here, we can change any parameter that we want to change. So, for instance, if we perform a scenario that calls for a vaccination campaign, so we can reduce the mortality of calves, we can easily introduce that into the model by going into the mortality of young females and young males, and for instance, reduce it until just 10%. So if we introduce the new value, and this will automatically has a reflection in the final results. What I'm gonna do is to change different aspects on both herd and feed part, and then we will go back to the results to see what those changes look like. So once we are finished with the changes in the first part, in the first module, we can go to the second one. In this case, it's feed. The feed pages are structured by herd type. So here we see that we are within cattle, the dairy herd, and also we can go to the beef section. In this case, we're going to change the diet of the dairy animals. The feed pages are structured as well very similarly between them, with the first box of a brief instructions, and then two boxes that summarize the ratio for different production systems. In this case, grassland, the first box, and mixed farm systems, the second box. As I said, this is just a summary, but if we want to modify the ratio, we can click directly into the button, and the model takes us to the detailed ratio, where we have the share of each feed ingredient with respect to the total intake. In this case, for instance, we are going to increase the share of grains and maize, so the diet has a higher digestibility and energy content. So, for instance, we can increase maize up to 10%, grains until 15. We can also change, for instance, the share of dry byproducts from grain industries, such as brands or meatlings, to 5%. And of course, we have to reduce some of the original values that are given by default. In this case, we will set sugarcane to 0, as well as the residues from rice and from sorghum. We can easily check whether the ratio adds up to 100% by going up and looking at the total percentage, and we see here that we are 1% over the total ratio, so we can easily correct for that. For instance, here. And although we are not exactly at 100%, this will work fine for demonstration purposes. We can easily do the same for the different feeding groups that are highlighted here. In this case, we have 3 different groups: adult females, adult maiden replacement animals, and finally the fattening animals. Again, for demonstration purposes, we're going to just change this first group, but this can also be replicated into the different groups. Needless to say, the same applies to the mixed farming system. It goes exactly the same. We clicked into the modify ratio, and it takes us to the particular diet for mixed systems. Once we have changed the feed ratio, in this case, we increased a little bit the content of maize and grains into the ratio. We can go to the final part of the simulation, which is the manure, by clicking directly here. And this page contains data on the share of each manure management system into the management, of course, of all the manure produced by a specific herd and by a specific production system. The systems that we are using in the model comes directly from IPCC, as can be seen here in this list. Box 1 contains the particular share of each system, as I said. And again, it works very similar. We have some reference values coming from our database, but we can modify any of them as we wish. So, for instance, we'll go to grassland-based systems, and we're gonna change a little bit. We're gonna increase the daily spread up to, for instance, 20%. Again, similarly here, we have a reminder that we have to make all the shares, of course, adding up to 100%. So we're gonna reduce 20% from solid storage. Once we're done with all the changes, and those are very short examples, and we can modify any parameter that is in a white cell, so it can be as complex and as complete as the user wants to. If we go back to results, we don't see the changes directly here, maybe because we have the aggregate results in this case. But if we go back to the cattle specific values, and we save this spreadsheet with another name, as we did before. So, for instance, we can do Kenya scenario. Once we have those two files, it's very easy to compare them, as we will always have the same structure. So, for a quick demonstration, I'm gonna show it. Comparison. Once we have all the files, we can easily go back to the baseline, and then, for instance, just compute the difference, and run the formula all the way through, of course, making the correct formula, and mixed systems. And as we see, the changes are reflected at each particular source of emissions, since we changed both the diet and also the animal numbers. For instance, one thing that it's quite important, we see here that the enteric fermentation emissions has been reduced by quite a significant number, given that we are feeding our animals with a higher quality material, such as maize or grains, instead of being all roughages, which is always a little bit more difficult to digest. So this is one brief example on cattle. We've seen that we changed the herd part, the feed part, and the manure. For the last part of this demonstration, we're gonna explain as well a very brief example on pigs. In this case, we will do the example with China. So again, the same procedure. We first type the name of our simulation. We select the particular region and the country within the region, and start the simulation. Here we click directly on pigs, which bring us to the particular page. What we can do this time is to change the animal parameters, the animal numbers. So we're gonna increase the production in industrial systems by increasing the amount of reproductive females and also the males. So we're gonna go up to 10 million, and here we've seen that the total number has changed, because this is of course dynamically changing as we modify the parameters. And for fattening for reproductive males, we also can increase up to 400,000. And another thing that we can change, for instance, it's similarly as we ddid before, it's the mortality of piglets. So if we conduct a vaccination campaign, or we conduct a particular project that improves the conditions of sows and piglets, so they don't die that much, we can go down up to for instance 5%. And once we change this, we go directly to the manure module, in which very similarly to the cattle again, we have the list of different systems as defined in IPCC that we can modify to reproduce our scenario. In this case, what we're going to do is increase the share of an aerobic digester up to 20%, for instance, and we reduce the uncovered anaerobic lagoon by the same amount. So we have 17. Again, we could change as well the diet and any other parameters, but to keep it short, that's our scenario for now. Again, we're back into the summary. As we see, the profile, it's quite different, since the livestock sectors in China and Kenya are very different from each other. Here, if we click in this case into the pigs tab, we are prompted into the detailed page where we can see the specific numbers from the different sources. In this case, divided by the production systems. We modified the industrial system, so in order not to repeat the demonstration twice, it would be the same as before. First, we should create a baseline scenario without changing any of the parameters, or of course setting our own baseline scenario based on the parameters that we have available. Save that file, then create the particular scenario, save the second file, and finally conduct the comparison, since the structure of the spreadsheets, it's always the same. In this way, the model, it's very easy to use and very fast to generate scenarios and be able to analyze how different policies and different measures can have a significant impact in terms of mitigating emissions, and also can provide some clear information to policymakers or to project planners to help prioritize intervention measures. So that's everything that we wanted to show you today. We hope that its demonstration it's helpful. In the website you can download the user guide, which also contains a step-by-step example that can be easily followed through, and has a detailed explanation on production systems and different parameters that can be changed. We will be very happy to hear your feedback, and thanks very much for your attention.